show that 2xy ax vector plus b square plus 2yz ay vector show that 2xy ax vector plus x square plus 2yz ay vector plus y square plus 1 az vector is irrotational. So what is the condition for irrotational? When your divergence equals to 0, it is called as solenoid. When your curve becomes 0, it is called as irrotational. But in here, curve so for curve, del cross f vector is equal to 0. This is the condition for irrotational. Curl of f vector should be equal to 0. Irrotational condition. So curl of f is equal to, so form a matrix. First one ax vector, second column ay vector, third column az vector, second row values del value enna dou by dou x into ax vector, dou by ay vector, dou by dou z az vector, third row value f vector, coefficient of ax vector is 2xy, coefficient of y is x square plus 2yz, coefficient of z is y square plus 1. Solve ax vector into dou by dou y into y square plus 1 minus dou by dou z x square plus 2y z minus ay vector into dou by dou x into y square plus 1 minus dou by dou z 2xy plus third term az vector into dou by dou x into x square plus 2yz minus dou by dou y into 2xy. Correct? Solve now. ax vector into 0. 0 minus of 2x. So again the 2x will get cancelled. Again plus 2y minus 2y will get cancelled. So finally 0. Correct now? Yes. Ax vector into 2y minus 2y minus ay vector is completely 0 plus az vector 2x minus 2x. So all values are 0. So del cross f vector becomes 0. Therefore the system is irrotational. Given function is irrotational. Next one, take it as position vector or positional vector. Position or positional vector. Next one. Next one. Take note, definition, positional vector, vector directed from origin towards any point, vector directed from origin towards any point is known as position vector. Vector directed from origin towards any point is known as position vector at that point. So for an example, if we have two vectors, a vector and b vector, it is represented as x1 ax vector plus x2 ay vector plus x3 a z vector. One more vector b vector which is equal to x1 y1 z1 x2 ax vector plus y2 ay vector plus z2 az vector. Then position vector will be from R A B. Position vector between two vectors a b will be equal to b vector minus a vector. Substitute x2 minus x1 ax vector plus y2 minus y1 ay vector plus z2 minus z1 az vector. So positional vector na it will be considering two vectors. In a whole vector find position value na what we have to consider the other vector is at origin 0 level assume 0, 0, 0. Now take note of problem. Given two vectors are suffix a vector given two vectors are a vector equal to minus ax vector minus point C, at a point C, 1, 3, 4. 1, 3, 4. Two vectors RA vector and RB vector at point 1, 3, 4. Find first subdivision. Find first subdivision RAB. RAB. Second subdivision AE vector. Third subdivision AC vector. AC vector. So first subdivision எப்படி கண்டுபிடிக்கிறது? RAB. Distance between two vectors. அப்பனா இது என்னது? Positional vector. ஓகேவா? So position or positional vector. Using that formula we have to solve it. Second one. So positional vector na RB minus RA. AB na B minus A. Second one AE vector. இது பேஸ் பண்ணி ப்ராப்ளம் சால்வ் பண்ணணும். AA vector called as unit vector. A vector nale it is a unit vector. So what is the formula for unit vector? A vector divided by modulus of A vector. Third one AAC vector. அப்படினா A and C கொடுத்திருக்காங்க. So first we need to solve using position vector. Then we need to solve using a unit vector. And formulas are so first one take it as positional vector. First subdivision RAB. So RAB is RB minus RA. So B minus A. Direct approach. RAB is 2AX vector plus 2AY vector plus 2AZ vector minus RA vector. RA is minus AX vector minus 3AY vector minus 4AZ vector. So RAB is RB minus RA. So coefficient of A is 2. Coefficient of AX is minus 1. Minus 1. Coefficient of AX is minus 1. Already minus it plus 1. Plus 1. AX vector plus 2 plus 2 minus 2 plus 3 AY vector. Third one 2 plus 4 AZ vector. So it is 3 times of AX vector plus 5 times of AY vector plus 6 times of AZ vector. First subdivision. Second subdivision unit vector AAA vector. AY and force transfer AZ vector. So we can frame RC as AX vector plus 3AY vector plus 4AZ vector. So for third subdivision, RAC AC vector. So RAC is RC minus RA. So RC value is AX vector plus 3AY vector plus 4AZ vector minus RA is minus AX vector minus 3AY vector minus 4AZ vector. So it is 1 plus 1 AX vector plus 3 plus 3 AY vector plus 4 plus 4 AZ vector. So 1 plus 1 2 AX vector plus 6 AY vector plus 8 AZ vector is R suffix AC. அதுக்கப்புறம் என்ன பண்ணுவீங்க? To find A vector, formula will be R AC vector divided by modulus of R AC vector. So R AC கண்டுபிடிச்சாச்சா? Next find modulus of R AC. So it is the root of magnitude of 2 the whole square, 6 the whole square plus 8 the whole square. So it is root of 4 plus 36 plus 64. So 40 plus 64 now 104 root of 104. Right? Now find your AA vector. So RAC is 2AX vector plus 6 AY vector plus 8 AZ vector divided by root of 104. Third subdivision. இங்கே ஏதாவது புரியாமல் இருக்கா? இது வரைக்கும் பிரச்சனை இல்லை. Cartesian, it is a system which is used. It is a system which is used to represent. It is a system which is used to represent a point in space. A point in space. So we are going to consider a point charge in a three-dimensional view. So when it is placed there, what happens to its change in its length, surface and angle. Those three things we are going to relate. We call it as coordinate system. It describes its differential length, surface and angle, projections and components. It describes the length, surface, angle, projections and components. So there are three types of coordinate systems. First one we call it as Cartesian coordinate system. Second one, cylindrical coordinate system. First one, Cartesian coordinate system. Second one, cylindrical coordinate system. Third one, spherical coordinate system. Spherical coordinate system. So in Cartesian coordinate system, we will be just replacing only the magnitude. Angles for the pathway matter. So here we will be going for three-dimensional view. X-axis, Y-axis, Z-axis. Only the magnitude will be considered. For cylindrical coordinate system, we will be considering only one angle. So first one it is represented as rho, phi, Z. For spherical coordinate system, we will be considering two angles. Rho, theta, phi. Rho, theta, phi. So here theta and phi represents your angle. Rho and x, y, z represents your magnitude. So in Cartesian, we are going to consider only the magnitude, not about the directions or angles. In cylindrical and spherical, we are going to consider the angle value as well as its directions along with their magnitude. So magnitude is represented by rho. So first one, take this Cartesian coordinate system. Cartesian coordinate system. So here we will be considering three axes. Right down. So all the three axes should be represented. All the three axes should be perpendicular to each other. So you will be having like this. Here we have x-axis, y-axis, z-axis. See, actually we can analyze using two axis component. X, y, z இப்படி போடலாம். Instead of that, x, y, z இப்படி போடலாம். சரியா? So when we consider this x, y, z, இது y, இது z. So x, y, z. 4 meters. இந்த டைரக்ஷன் இருக்கும். சில புக்ல இந்த மாதிரி டைரக்ஷனையும் போட்டுருப்பாங்க. A partition coordinate system. சரியா? So x, y, z 3 axis. இதுல என்னென்ன கண்டுபிடிக்கணும் சொல்றேன்? Differential length, differential surface, differential volume. So meaning of differential அப்படின்னா change in length, change in surface, change in volume. சரியா? So since we have 3 components, 3 axis components, we can change the length value, we can change your surface value, we can change your volume. Angles will be represent ஆகாது. So if we are considering this P as a point charge in your free space, இதுல எப்படி போடலாம்? ஒரு cube மாதிரி கன்சிடர் பண்ணிக்கலாமா? Cube or square of the room. So in this, where is your x-axis, y-axis, z-axis? So this represents your y-axis. This one represents your z-axis. Perpendicular to these two, you will be having a x-axis. Now, if the point charge is moved to another position, take it as P dash. If any produce out here, from P it is moving to another place. So you will be having a positional vector over here. இங்கே உங்களுக்கு ஒரு டிஸ்டன்ஸ் வந்து இன்னொரு டிஸ்டன்ஸ்க்கு போயிடுச்சு. ஸோ பொசிஷனல் வெக்டர்ஸ் இங்கே இந்த இடத்துல ஃபார்ம் ஆகும். ஸோ இப்போ P dash இந்த பாயிண்ட் மாறிடுச்சுன்னா your cube will be moved to another position. வேற பொசிஷன் இங்கேருந்து வேற பொசிஷனுக்கு போயிடுச்சு. ஸோ this will be your new y value, y dash, z dash, x dash. So this will be, there is a change in its position due to x-axis, y-axis as well as z-axis. So this is your Cartesian coordinate system. புரியுதா? ஒரு பாயிண்ட் சார்ஜ் ஒரு ஆக்சிஸ்ல இருக்கு. ஃபர்ஸ்ட் வந்து ரெஸ்ட் பொசிஷன்ல இருக்கும்போது அதோட டிஸ்டன்ஸ் x, y, z with respect to axis எடுத்துக்கணும். இப்போ அதே பாயிண்ட் சார்ஜ் ஒரு இடத்துல இன்னொரு பொசிஷனுக்கு மாற்றும் போது என்னன்னா அது பொசிஷன் gets vary. பொசிஷன் வேரி ஆகிறதுனால இதோட லென்த் ஆக்சிஸோட ஆக்சிஸ் எக்ஸ்ன்றது வேற பொசிஷனுக்கு மாறி இருக்கு. ஸோ அப்போ there will be a change in distance in all the 3 axes, x axis, y axis, z axis. So you will be having a change in length. சரியா? Once we have change in length, we will be having change in surface as well as volume. புரியுதா? ஸோ கார்ட்டீசியன்றது ஒன்றுமே இல்லை. 3 axisல ஒரு பாயிண்ட் சார்ஜ் ஃப்ரீ ஸ்பேஸ்ல ரெஸ்ட் பொசிஷன்ல இருக்கு. After some period of time, it is moved to another position. So you will be having a formation of positional vector. Then we will be having a change in its length value. So if length changes, your surface and volume also changes. So initially, so this is your final value. So your x is varying from this position to another position. So this distance we can take it as, distance is taken as dx. So அதே போல இந்த இடத்துல ஒரு change இருக்குப்பா, change in it. So it is your dz. So if it is changing here, it will be your dy. Okay, so differential length, initially it is at x, y, z. After the change, x is changed as dx, y is changed as dy, z is changed as dz. So differential length can be written in terms of magnitude. Magnitude மேலே என்ன பண்ணணும்? We have to take square root of dx the whole square plus dy the whole square plus dz the whole square. இது வந்து length. So differential surface. So if you are going for surface na என்ன இருக்கும்? Area. Area na length into breadth. Only 2 areas you can find out. So our differential surface will be represented as ds. இதுல என்ன இருக்குன்னு சொன்னேன்? ரெண்டு ஆக்சிஸ் தான் இருக்கும். length into breadth னு இருக்கும்போது ஏதாவது ரெண்டு ஆக்சிஸ் தான் வரும். மூணு ஆக்சிஸ் வராது. So we can write ஒரு ஆக்சிஸ் எடுத்துக்கிட்டீங்கன்னா we have to write that axis write the other two axes. இப்போ நான் x எடுக்கும்போது இப்போ நான் என்ன எழுதணும்? y and z I have to consider. So y is changed as dy, z is changed as dz. So instead of x, now y எடுத்துட்டேன்னா surface will be
dx
dx and dz. So if you are considering z axis now, this dx dy. So this is your differential surface. Third one, differential volume. So volume என்னது? Length into breadth into height. மூணு axis நம்ம consider பண்ணுவோம். சரியா? So differential volume will be